Sure.
Okay, so the recording has started. Yeah, you can share your screen.
Okay. So is it visible, my screen?
No, it'll take some time to load up.
Okay.
Yeah, I see it now.
So I'm directly fetching it from SlideShare. So maybe like that will be easy. At the end of the session, I can give you the link uh, so that everyone can, view the slides.
Okay.
So shall we get started?
Yes, please.
Hello, everyone. My name is Ajeet, and today I am going to bring you a kind of very introductory session on Docker. I'm a part of a Docker Captain program, and we work very closely with the Docker developers and the maintainers. So let us get started. So who am I? I am right now working in Dell EMC as a senior system development engineer. And the first half of my career has been in CGI and VMware, where I worked around for 2 years. And since the last 6 years, I've been working as a project lead engineer in Dell EMC as a system integration engineer. I am more into a kind of an ops team rather than the developer. So most probably I won't go deep. I won't deep dive into Docker containers architecture, but to give you a kind of an introduction to how the Docker container can be built or images can be built. And this is my Twitter handler, Ajeet as Raina. You can see me tweeting frequently on Docker containers. Apart from this professional career, I've been actually, traveling a lot. Earlier this year, I was in Austin as a part of a Docker Captain program where I conducted a workshop in Austin. And the last year I was in Germany. And I'm also a part of a code catalyst team that is from Dell EMC. There are around 18 code catalyst members. And what we do basically is we go ahead and contribute in terms of the blogs. Collabnix.com, this is my personal website. You can see whatever the Docker releases or the new releases or the upcomings happens. I try to bring it in a terms of blogs. And you can see around 100 plus blogs in collabnix.com. So feel free to visit the site. Okay, so this is going to be an agenda today. I'm going to talk about how the shift from monolithic to microservice architecture is happening across the enterprise IT. And then I'm going to jump on what is Docker, what problem does Docker solve for us. And this becomes really important, right, when the new technologies come into the market. So you try to jump into it, but we really need to know what problem it solves for us. Then I'm going to talk about how Docker is different from VM and CM. CM is configuration management, because I can hear that most of the people try to compare it with the configuration management tool like Puppet and Ansible, but Docker is entirely different. Then I will move on to Docker build, ship, and run workflow, how Docker actually works, and little about, if I get time, I can talk about Docker ecosystem and native offering, and little about the tools. And I have a demo which for 10 minutes, so 5 to 10 minutes. So let us get started. So if you go back 10 to 15 years ago, you can see that your application was a kind of a monolithic application, where when a server reaches to your data center, right, you try to build up a kind of an application stack. And this is a kind of a one big server, and you dump all your application, which can be built on a single stack, actually, which can be in the form of .NET or Java, right? It's long-lived because what you do is you build an application, though there is a load balancing concept, but still it is a monolithic application. But today, if you see, right, the application has changed dramatically. You have an apps which are constantly developing. Your new versions are coming like in next 4 to 6 months. And this is basically a change which has come. The earlier, when you develop an application, the changes happens once in a year or once in a 2 years, right? Right now, because of the different kind of a DevOps tool the developers and the ops team uses, the application are changing very frequently. And the important point here is these applications are very loosely coupled. And this is what we call as a microservices. You have two services, say one service as a payment gateway service or other is a credit card service. Take an example of Amazon. You have a shopping cart service, you have a payment service, right? These services basically are talking to each other. And these are the small microservices, and they have an API to talk to each other. So, and the other reason is these services are deployed in a multitude of servers. So you don't have one service running in one server and you have the other service running in other servers. So you can have two services running in a one particular server, and then you have other two services running on a different in a cloud, right? So one service can be in the public cloud and one service can be in private cloud, and they are talking to each other through APIs. So let's take an example. So once upon a time, your software stack looked like this. You have a web server, front end and back end working, running on a single server. But right now, it looks like a very a much distributed complex. So you have a front end service talking to the back end service, and say in the front end, you have a WordPress for a particular version of the WordPress. And then you can, when you go to the production, right, the WordPress version can be different, or a different operating system might be used in the production, right? So when you develop an application in your laptop, the environment when you develop that application, when it goes to the tester or the build environment, and when you have a production environment, the environments are completely different. You never know that the code which worked very well on your laptop is basically running in the production environment. So you have a web front end, we have analytics, DB, Q, and then the Redis is running in the background. You have an API endpoints, the particular version of Python 2.7, 3.6 might be running, right? And you have a more complicated software stack running on a more complicated hardware stack. And that is the problem, right, today. When you have a single server, when you have a monolithic architecture, that is one single problem. How many times have you heard developers saying like it works in my environment, right? There is always there is a lot of people to blame on. So something which you develop on top of Ubuntu 16.04 might not work on 17.04, right? It's a different version of Windows, different version of Ubuntu. So you have a complicated, a distributed, complex environment or an OS running on a different kind of servers. And this is something which affects the development, test and QA, production, and a scale-out architecture, right? So a developer running a particular version of Python on a development machine or in a laptop, when it goes in the form of a virtual machine, it might have a different kind of environment. And the same when it goes to the server on the cloud, you might have a different difficulty in getting it up, right? Just imagine the application which you build on a laptop, when it goes to the cloud. Take an example of Amazon. Amazon has its own AMI instances, and that is a kind of a stripped down version of the Linux, right? So you never know your application is going to run or it is going to solve all the dependencies. So in nutshell, it is very easy to say that the shipping code is damn too hard. Whatever you have developed in your on premises might not work on the customer end. And this should not be hard because we have so many sophisticated tools which is present with us. We can make it very easy and we can reproduce, we can make it work in the customer side, right? So this problem is not new to the other industry. Like one of the example I can take it as a shipping industry. So if you see in a shipping industry, this problem was solved around 40 years ago, where they have an inter-container kind of stuff where they used to package their goods. So if you take an example of pianos, if the shipping corporation, right, if the shipping company has to ship pianos with potatoes or drums, so there is a way, right? You package it down in the form of a kind of a containers. So this is how it looks like. And every goods which you label is a kind of an indication, right? If you compare it with the software development software development industry, right? So we have developers, we have an ops team. So developers has to just concentrate on what is going inside a kind of a container, and whereas the developers, the ops team has to concentrate on how to run it, right? So there is a kind of a differentiated line in between that, and that makes more easy. So the solution was inter containers, which will basically you will be labeling the goods and sending it. So just to take an example of Amazon. So today, when you order for a mobile, right? So you get the way it is packed at the Amazon office, then the way it is shipped to your home, to your house or the residence, right? It is same. There is no change, right? So the same thing is what we are trying to solve in terms of the server world. And this is where the Docker comes. It brings a standardization of the packaging goods, and no matter how you build it, no matter in what programming language you build it, when it gets shipped to the customer is going to, or when it's shipped to the other end, whether it is in a cloud or in a server or in on-premises, it is going to behave same. So what is Docker? So as of today, I can see that there has been a multiple difficulty, especially in understanding. So what is a Docker? So Docker is basically some people think of it as a virtualization tool or as a VMware or a virtual box, whereas in the other sense, some people might think of it as a configuration management or Chef or Ansible. Or some other people might think of it as a VM manager like a Vagrant and Puppet. But if you ask me, Docker is a little different here. It occupies a sweet spot here. So if you see this spectrum on the left-hand side, you have a kind of when the server reaches your data center, right? So you build up a server and you try to install an application on top of that, and that is a less portable. On the right-hand side, when you see that there is a lot of overhead, and this is a traditional VM where you basically it is portable. You can basically build all the application and package it. It is very similar to the VM, or Docker might sound different, very similar to the VMs, but Docker occupies a sweet spot here where it is again more portable and minimal overhead, and this is how it looks like. So I have a slide which talks about how the Docker is different from the virtual machine. So as a Docker is basically a company as well as a product. It is developed by .cloud, and it is basically a framework which they built it as a platform as a service around 4 years back. It is a cross-platform. It has a cross-platform nature and friendliness towards the system admin and developers. It is both for the developers as well as the system administrators, and the developers has to concentrate on building the application and getting them run inside the containers, whereas a system administrator has to basically run it in deployment, or just have to concentrate on how to deploy it, right? So Docker today is possible to set up in any of the OS, be it Linux or Linux. It works the same way, and it guarantees the same way which you do it, whether in your development desktop or bare metal servers or virtual machines or the data center. Basically, Docker is a tool which can package your application and all its dependencies. And this is really important because you are building an application along with all its dependencies, and it is to ensure that it runs in any environment you ship it to. And implementation is based on the concept of image. So I have a slide which talks about the Docker image in detail. I can go through that. So the next slide, which is really important, is like one who is coming from the virtualization world, right? They might think like, especially about Docker containers, very much look like a VMs, right? But Docker containers are not VM, and let me show you a detailed information regarding this. So Docker containers are not VM. It's not quite like a VM because in terms of VMs, you have a kind of each VM has its own kernel, but here, in case of containers, basically they uses the host kernel, and they don't boot a different container OS, right? Because it's not like a VM, right, where you have each and every VM has its own operating system. But in case of containers, we just share the container, just has an user space of an application, right? So to basically understand what Docker is, think of it as kind of just a single normal process which is running on the host machine. And in terms of VMs, it is kind of a complete server hardware virtualization, right? But in this, it is kind of a process virtualization. Let me talk about similarity, because that will give a complete idea about how the Docker is basically different from virtual machines. So virtual machines, under the virtual machine, the process in one VM, you can't see the process in other VMs, right? Because they are completely isolated. And unless and until you use some kind of tool where you SSH to the machine and see what are the process running, but the process or every VM is basically isolated unless there is no any kind of a networking protocol in between them. But process in containers, yes, they are again similar. Every container is a kind of an isolated environment. So in terms of this, both virtual machine and Dockers has a similarity. In the same way, each VM has its own root file system. Each container has, again, its own root file system if you don't consider the kernel. Like each VM, the containers also get a kind of a virtual adapter network. It has a separate IP, it has separate port. So when you talk about container is just a user space of an operating system, whereas VM has both user space and the kernel space. And the other similarity could be like VM is a running instance of physical files like VMX and VMDK, whereas in terms of containers, yes, they are running instances of the Docker image. Let us look at the differences. Virtual machine, it runs its own OS. So if you have a virtual machine where you have installed CentOS or Ubuntu, it will have its own OS. Whereas in a Docker, all the containers share the same kernel of the host. So it doesn't have its own OS. It's just a user space of an operating system it has, but the kernel is the shareable kernel. The boot time of virtual machine is in minutes, whereas the containers instantiate in seconds. So they're very fast. I can show you in the demo where you can bring up the Ubuntu container in just seconds or the milliseconds. VM snapshots are used as per demand basis where you use it, but when we talk about the Docker images, they are basically built on the foundation on top of the layers, because the Docker, when you say Docker image, is basically a group of layers. And there are a lot of images, right? So the bigger the images, the bigger is the size of your application. You can't run the diff command directly to the VMs. Okay, so it is not easy to do that, but in case of images, yes, you can run a diff command and it can be version controlled. It works very similar to how the GitHub works. And here it brings a kind of a concept of collaboration tool. You can't run a lot of couple of VMs on an average laptop. So in an average laptop, if you go ahead and create a VMs, right? If I take a Windows VM itself, by default it takes around 30 to 40 GB of space, right? So, but in case of containers, they are in like KBs and MBs, right? The smallest container which we have today is of 450 kilobytes, 450 bytes. So this was one effort which we were like doing it in the like through the Twitter, and all the Docker captains were trying to build it. So one of the Docker captain has built it in 450 bytes. And so only one VM can be started from one set of VMX and VMDK files, whereas you can have a multiple Docker containers which can be started from one Docker image. So these are the basic differences in between the VMs and Docker. In a simple way, if you want to understand what is the difference between VM and Docker, just think of it as VM as a full-fledged house. So when you have an independent house, which you have, right, the whole family basically shares a kind of a plumbing, electricity, right? And you basically own that house unless and until you have a studio apartment, right? But containers, you can treat it as an apartment because every flat in the apartment share a plumbing and electricity, a kind of a gas connectivity. So treat containers as a kind of an apartment, whereas VMs as an independent houses. I think that will make things clear. if you go into the technical details of the containers versus VM, this is how it looks like on the left hand side. If you see the lowest, the base layer in infrastructure, and on top of that, you have a host OS, and you have directly a Docker engine running on top of the host OS, and on top of that, you bring up the containers. Whereas in terms of VMs, you have a layer of hypervisor layer, and on top of your infrastructure, and again on top of that you have a guest operating system. So this diagram shows about you can run a Docker again on top of your guest operating system. So Docker and VMs can coexist. So this is what this picture depicts, and it says like, and today the VMware claims the Docker to be they recommend that to run the Docker on top of the VMs because they truly believe that VMware has been there for last 10 years, right? It brings you all the security features. It has a number of features like a vMotion and DRS and HA, and they truly believe that if you have a containers, you can run a containers on top of your virtual machines too. So one example could be here, Windows Server 2016. You have an infrastructure. On top of that, you install a Windows OS, which will be kind of a host OS, and you run on top of that, you run a Docker engine, and this Docker engine is going to help to run the containers on top of it. So let us go through a Docker vocabulary and what are the terms or terminologies which have been used in the Docker. So these are the very basic Docker terminologies or vocabulary, and I can see that there has been like, especially you have to, when you are getting started with the Dockers or hands-on, or you want to really try it out. So these are the basic terms which you should be aware of. The first thing is a Docker image, which tells you like how to store your application. It basically forms the basis of the Docker container, and this is a static instance of a VM. When you say a running instance of a VM, it is very similar to how the containers. So when you run an image, it becomes a container, right? So that is the difference between Docker and Docker containers. So you have a Docker engine, which is like an heart of the Docker, which basically creates, ships, runs the Docker containers, which can be deployed on multitude of physical and the virtual host. And we do have a kind of a registry service, which is called as Docker Hub. And it is just like a GitHub where you publish an image so that the other developers or an ops team can pull it and then can run it. Now let me go a little into detail of image layering, how it looks like. So a typical Docker image looks like this when you have a base image, and which is a static snapshot of the container's configuration. So this base image is basically a read-only, whereas you keep on adding in software on top of that, and all it does, it basically the other layer, the topmost layer, is a writable layer, and that is basically the containers. So a static snapshot of a container's configuration is your Docker image, which is read-only. It is never modified. And all the changes which you make on top of this image is what comes on the topmost writable layer. And this is where you basically build your application or deploy your application. So these are the basic Docker commands. When you get started with the Docker, I can show you in the demo. So you pull the Docker image with Docker pull and your image name. So your image name is basically your Docker Hub ID followed by your image name, which you provide. And this is something which is placed at Docker Hub. And when you pull it, it basically gets pulled in your local host machine. You can go ahead and list out this image with the Docker image ls, and then you go ahead and run the containers out of it. So when you have an image and when you say Docker container run or Docker run, it basically runs that particular image, and the image which you are seeing, right, Ajeet Raina slash cat web is basically is a kind of an application which will demonstrate a kind of a GIF file on the web browser. If you look at this command, docker container run -d is a daemon. So I want this application to be running for a long lasting purpose, and I can go ahead and usually how you do is if you compare it to the VM, right, you usually run the service and that service gets opened in terms of a ports, right? So it is -p, it denotes the first 5000 denotes it is like a host machine. The port is mounted to your container instance. So you should, after running this command, you should be able to get this application running at port 5000. Stopping the containers, you have a Docker container stop. So this is a kind of a Docker CLI commands which you can use. Let me see if I can show you a kind of a demo. Let me quickly jump into the demo. So meanwhile, is there any question which you guys have?
Yeah, Ajeet. So let me read those out. So the first question is, can we containerize any number of applications within one container, or is it a best practice to do a one-to-one mapping? So suppose I have two services, like you were explaining the microservices architecture, right? Suppose I have two services. Would you advise me to put both of them in a single container, or is it a best practice to put them in two separate containers?
Yeah, it's a really very good question. So if you see, right, usually there is a term called as a dual factor wrap, so which talks about how the microservices or how the application should look like. And the recommendation which we have is like running a one container, one process per container. So if you have a web server running, put it inside one container. And when you have any of the database running, which you can application running, you can put it in the separate container. But if you talk about the legacy application, so I have an experience in the past 1 year where I built a legacy application and try to microsize it. So the things are going to break. So unless and until your application is not breaking up, you can go ahead and basically containerize per application in per container or per services per container. But few of the application, what I have seen is when you try to build a microservices a lot with your legacy application which you use, things are tend to get broken. So yes, per process, per application, per process, per service running on a per container. That is the recommendation.
Okay, and there's another question which says, how is a Docker container different from a Kubernetes container? When is it advisable to go for Docker or Kubernetes? So I think the comparison here is like apple to oranges, because Docker Swarm is something which can be compared with Kubernetes, right? Because it's sort of the orchestration and the deployment tool. But if I'd like you to answer that, because I don't have much experience with the Kubernetes as well.
Yeah, so if you look at the Kubernetes, right, Kubernetes, again, it uses a Docker Swarm. Kubernetes again uses the Docker containers to bring up the application. So there has been a recent effort where soon you will see that they are coming with. So Docker is kind of a runtime, right? Runtime environment which is provides, and there is a new project which is coming up from CNCF, which is a kind of a CRIO. And soon you will see that Kubernetes will be using that alternative technology. But today, yes, Kubernetes uses Docker for most of its orchestration, and Kubernetes is basically a work. Google has been using it for around like last 13 to 14 years, and they use the containers. And right now, Kubernetes is one collaboration which is coming from the VMware, Red Hat, and Google. And moreover, when you talk about Kubernetes, it talks about the orchestration features, and that is basically a main, I would say, the one kind of a competitor to Docker Swarm. So today, Kubernetes, yes, uses a Docker to bring up the orchestration, but soon you will see that it might get shifted to the other orchestration platform too.
Okay, so to summarize the answer to the question, Kubernetes is just an orchestration platform which basically deploys Docker containers for you, right? And comparing, and the question was when is it advisable to go for Docker and for Kubernetes? I think that's a wrong question because it should be when is it advisable to go for Docker Swarm or Kubernetes, right? Because
Yeah.
Kubernetes
So
behind the scene
so as
deploys Docker containers.
Yeah, so as of today, Kubernetes is, I think, a full-fledged kind of is recommended for the production environment. But you do see that there has been a lot of feature which is coming up with the Docker Swarm. Docker Swarm is also used in the production environment. So it's just like a community supports, and today the Kubernetes has been supported for multitude of big companies, and it has been recommended for the production. But Docker Swarm is something which is like 1.5 year old and still coming up. So I do believe that Docker Swarm is going to be a kind of a very is going to be a kind of a production ready. But at this point of time, if you are looking for a production ready environment, yes, Kubernetes is recommended.
Okay, okay. Thank you, Ajit. I think we should move on. Let's
Okay,
move on.
so
Yeah,
so
questions at the later point
yeah,
in time. Yep.
okay, fine. Okay, so let me jump directly into a demo kind of because this is something which really interests me, and it will give you an idea like how the Docker containers, or Docker images look like. So if you would have seen that, can you see my screen? Is my screen visible to you all?
Yes, 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 we can see, Ajeet.
Okay, fine. So this is a site called as a Play with Docker. It has been created by two of the Docker captains, and I think this is the best place to get started with Docker. So all you have to do is you can go to the web browser and type play-with-docker, and it will give an interface. So this is basically an interface which is running in AWS, and at the maximum you can create around 5 instances. On the left hand side you will see the instances. You can just add an instance, like once I click it, it will basically bring up one of the instances, and your instances is up based on their network. uh, you will see an IP address here. This is an IP address which is again coming from the AWS, and I can go ahead and say Docker version. So Docker version is a command which indicates that your Docker is already up and running. So I have the latest Docker version 1706, one community edition. So this is a community edition which is running on this particular platform. Um, to list out the images, as of now, I don't have any image, so I can say Docker images ls, and as of now, it doesn't show me any image because I haven't created that. So let us think like I am building one application, right, or a front end or a web server. So all I can do is I want to know how many, what are the images it's present in the Docker Hub. So I can go ahead and say Docker search Nginx. So Nginx is a web server, so I can see a couple of images here. So you can directly go to the Docker Hub and check what are the images are present, and in the Docker Hub for each image there is a description which has been written, how to run it, and how to deploy your application. So feel free to visit the Docker Hub and spend time on that, so that you will get to know what kind of application basically has been pushed there. So let me start with a very basic pull image. So I will do the Docker pull and say Ubuntu. So when I say Docker pull Ubuntu, so by default it will pull the Ubuntu image, and if you see, already I have this image already present in my machine. So it's very quick, right? So you just pulled an Ubuntu OS, which is only the user space of an application. It doesn't hold the kernel space. So as of now, if I want to check if this container is running, so I don't have any container running because I just pulled this image, and this image is a kind of a static binary of a whole application, right? So this is a base image and with no application. So let me run this particular image and run this particular command. So what this command is going to do is when I say Docker run Ubuntu date, it will basically it will try to see in the local directory in the local machine whether I have an Ubuntu image or not. It will try to pull that image. Since we have already pulled it, so it won't do it. And it will try to create a file system. It will try to create a network. It will assign an IP address. It will assign a kind of it will basically bring up this complete OS, the bash shell, and it is going to run a date command into it and then exit. You just imagine that how fast it is going to be. I just go ahead and press enter, and you see the date command. So what it did, it basically went into that particular image, created a file system, started a network services, bring up the terminal, and then it executed a kind of a date command and then exited. So you can see the date. So this date is basically coming from inside the container and not your host machine. So if you look at this machine, this is basically an Alpine machine, Alpine instances. In the same way, I can create more instances. So if I really want to, if I see Docker PS, it won't show me the container because that container has already existed. It did it work, it displayed the date command and it exited. Now, if I want to do something with this particular container, I can say run ITD. I means interactive, T means it is like a sudo terminal. Daemon is one which it will run in the background. And I say this Ubuntu and I will start up the bash shell. So when I do it, it gives me a particular ID. This is a container ID. Now, if I say Docker PS, it will show me the container. Now I have an Ubuntu container running inside this host OS. If I want to basically go into this, I can just take the first two basically kind of a alphanumeric character, and then I say attach. When I do it, and you press enter, you are basically inside the container. Now, if I see here, I'm inside the Ubuntu container. So if you see, right, just compare it to the VM. In terms of VM, if I ask you to create a VM, run the date command and shut it down, now that is going to take a minutes, right? So you just have to bring it up, first install the operating system. You might use a configuration management tool for that, but it is so fast, right? It happens in just a millisecond. I can say control PQ and I am out of this container. It's very similar to how you come out of the VM, right? So I have an Ubuntu image, Ubuntu container which is running. In the same way, let me show you an application. So let me pick up one of the Nginx server and then run a particular service or web server. So it is very similar to how it runs. So I say docker run -d -p. I want to expose the port 80 and run Nginx. Okay. So what this command will do is it will basically fetch the Nginx from Docker Hub if it is not present in the local machine. It will run it. It will create a file system for it. It will bring up a network services and expose it in port 80 and show it on an interface. So if I run it, you will just see the whole application stack, whole application is coming up, and soon you will see the port number here. You just click on the port number and your Nginx is ready. Now just imagine if I build up an old application, you have a web server up and running on top of this instance. So you bring up the application so quickly, so fast. So let me go through that. Let me show you the other application. So usually, say I'm a developer and I have a kind of a project in the GitHub repo. So let me show you one cool example here. So in Play with Docker, I will just I will showcase you how to. Now this we are talking about a kind of an application we are deploying on a single server, right? So if you go to the instances here, click on this, you will see that there is a template which has already been defined to build up a swarm. So I won't deep dive into the swarm, just let me show you how efficiently the whole application can come up. So I can select this particular template where I have 3 managers and 2 workers. I can click on this. Since one of the application is already running, I will go ahead and delete it. So let me delete it and bring up, just think of it as like I have a 5 node cluster where I have one manager and the multiple worker nodes. So since I haven't touched about the Docker Swarm, I won't go into the complexity, but I just wanted to show you how easily it can be. So let me show an application. So I have an application which I have hosted in my GitHub by name Ajeet Raina Docker 101. Okay, there is something which I'm missing it. Okay. So
There is a
very
typo.
small. Yeah, there's a typo here. So suppose developers build an point of an application and and he has like uploaded in the GitHub repo. I can go inside it. So I can go inside this particular. So I have a directory called play with Docker, and suppose I want to show you how to bring up a kind of a fancy visualizer tool, right? So I will talk about Docker Compose. Let me show you the kind of the things you can build it up. So I just type Docker Compose up -d, and it should bring up my whole application. So let me go back and show you something here. Okay. So before I show you that application, let me go through a few of the other way where you can build an application. So you have a concept of called as a Dockerfile, which can help you to build up, which is basically which you can run across the other machines like Windows and Linux. So the Dockerfile is a text file which can help you to build a kind of a Docker container, right? Or build a Docker image. So I haven't taken an example of Windows example and one Linux example. On the top, you can see that this is how the Docker file look like for Windows IS server. So from Microsoft, Windows Server code is very much similar to how we use the Docker pull command. So it is going to pull the command, and then you run a kind of a PowerShell command to add a Windows feature or Windows feature called as a web server, and then you try to ping a local host to verify that it is working fine. So this simple Docker file, which is a kind of a text file, can help you to build the containers. And why we use that? Why? Because every time we can't do Docker pull, Docker run, and then build an application and come out of it and then commit it. So this is a simple way to build a Docker image. In the lower end, you can see that it is the example is for the Linux to bring up the Apache server. So I have from Ajeet Raina Apache. So this is an Apache image which I have created, and then you can pick up any of the image of your choice, and then you can install few of the packages, and you can go ahead and expose the port 80 and 443 and run the command. So this is a sample Dockerfile command. When you try to build an image on a single host machine, what about when you want to build an image, multiple images? So I can't go around and create a multiple Docker file. So Docker team came up with one of the concept called as a Docker Compose, and this Docker Compose is a place where you build a microservices. You can have a multiple services talking to each other. So if you see, if it is visible to you guys, if you see, there are two basically images. The backend two services, backend services and front end services. The backend service is the DB, and the front end is a WordPress. And I have specified all the environmental variables, all the ports under this particular backend service, and the similar for the front end service. So you can basically specify your small microservices in terms of a Docker Compose. So let me show you a very let us show in the let us get it shown in the play with Docker. So I just ran this command Docker Compose -d, and the whole application comes up. So when you click on this, I can see a fancy kind of an interface which shows the containers, right? Which shows that there are particular nodes. Now I will go ahead and bring up some application and see that how it displays under that. So I have a project called as the WordPress, and I have a Docker Compose file under it. So I will go ahead, and when I talk about a number of services running in a particular host, basically I mean that you have you can use a Docker Compose. But when you talk about a clustering, Docker Compose in terms of cluster, so you have a command called as Docker stack deploy. It is very similar to how the Docker Compose on terms of a cluster of the machine, and I can say my app. So you can just see that it just took a seconds to bring up my application, and if I go here and click it, we'll see that the 2 nodes cluster is coming up. We have the 2 of the nodes. It is because I have a Docker Compose where I've specified that this particular image has to run on the worker nodes. So that's why it has come up. And within a few minutes of time, you will see that the whole WordPress coming up. So if you see that the whole has come up, I can go ahead and configure a DB and the front end, and this is how the things works, right? So in just a seconds, I'm bringing up the whole application. In the same way, you can build a multiple application across the Swarm. Maybe like the next time I can talk about the Swarm in detail, but this is just to showcase you that building an application becomes more and more easy when we work with the Docker. So I think I'm pretty much done.
Okay, Ajeet. So what I'll do is I'll unmute the participants. So if they have any question, they can use their microphones to ask you that.
Sure.
Okay, if you have questions, you can ask Ajeet one by one. So Ajeet, I have a question. Docker Compose is the tool which I'd use if I want to deploy a multi-tier microservices architecture application on a single node, right? And Docker stack
Yeah.
deploy would be when I want to use when I want to deploy my application and scale it out across a cluster, right? So that's the difference.
Yeah.
Okay.
Yeah. Correct.
And I went to the GitHub repository for Docker Compose. It's a single file written in Python, I guess.
Which one? Docker
Docker Compose.
Compose?
Yeah.
Yeah. So if you see, so the thing is, most of the programming language which has been used, the Go language,
Mhm.
but Docker Compose is something which you can use it to build any kind of application.
Mhm. So I think what it does, it just passes your YAML file and just brings up the container on a particular host, right? It doesn't do much than that.
Yeah. So it means if you want to, yes, you can go ahead and specify all those. If you look at, if you're really interested, right, you can look at here. Let me show you. So the whatever I have been running here, uh, this is how it looks like. Let me show you this. So if you look at here in terms of Docker stack deploy, so you basically go ahead and kind of declare one DB with a particular image, and then since the database, you never run a kind of you never put the data inside a container. You always put it outside the container, right? So here you are mounting a volume here to where leave MySQL to DB data, and this has to be on the host machine. So I am mounting it for the persistent storage. Then I can go ahead and pass the environmental variable because this is what you need for the MySQL database, right?
Yep.
And what I have done here is I have specified the constraint as node dot role is equal to worker. So what does it mean? That this container will always go and sit on the worker, and that is the reason you are seeing here. Why it is sitting on worker 1 and worker 2? It is the reason why, because I am passing that constraint here. And then I need one replicas of this particular container. So replicas is one. On the same way, if I want to do an update, that will happen a rollback update, or the next update should happen in the terms of a particular 10 seconds. And whenever this container goes down, so there is a restart policy to bring it up.
Mhm.
So this is a kind of one of the template how we define it.
Okay. So all these syntax will be documented at the Docker's documentation pages, right?
Yes.
Okay.
Yeah.
Okay, thanks for the session, Ajeet. I don't think there are any questions. People are asking questions related to Windows containers. So I just wanted to say that we'll do a Windows specific Docker session given by Babu from EMC. He'll be doing that for us because he has been using Windows containers for a while. That's we are still that's still in progress, and we would like you to come back and give us more sessions on Docker Swarm, Linux Kit, Moby, and all those the new and cooler stuff which is coming to Docker, right? So we'll keep scheduling those, and we'll keep asking you to come back and speak for us.
Yeah, sure. Like,
So, guys, before we finish this session, I, we want to know your feedback. So you can write on the chat window, and I've already sent one comment. So you can start writing your feedback over here, and we will collect it, and we'll make sure take this feedback in the upcoming session.
Yeah, and this particular recording will be uploaded to YouTube, and it will be posted in the GitHub repository. So in the GitHub repository, there'll be a folder called Docker Introduction to Docker. There will be a README file. Just browse to that point, and there'll be a link to the video recording and the slide as well.
and I have a last slide for the references. So you can visit my website, collabnix.com. This is a tool which I showcase, play with Docker. You can visit it and get started. You don't have to depend on how to install it. So everything comes pre-installed with Docker. And usually when people ask me the question how to get started, I think the best resource is docs.docker.com because they have plenty of resources there to learn Docker. So I would recommend everyone to get started with it, whoever is interested. So I'm sure like they will like the documentation which has been done there.
Yep. Okay. Thanks, Ajit.